Greetings everyone, and welcome to another example using the ideas of classical probability. Our example is at the Red Barn Market, you can get an ice cream cone with 2 scoops of ice cream. Let's assume that you must choose 2 different flavors for your scoops, and that which flavor is on top doesn't matter. Let's further assume that all flavors are equally likely. Our flavors available are chocolate, vanilla, strawberry, and butterscotch. So we're going to start by asking, how many different ice cream cones are possible? So the reason that this word problem is so long is because there's a whole bunch of restrictions on what combinations you're allowed. So we're just going to do the brute force method. It's true that there are other methods that are a little bit more sophisticated, but for the purposes of this course, just writing them out is going to be just fine. So if our first scoop is chocolate, in the problem description, it says you must choose 2 different flavors. So we can't have chocolate and chocolate. We could have chocolate and vanilla. We could have chocolate and strawberry, or chocolate and butterscotch. If the one of the scoops is vanilla, well, we could have chocolate for the other one, but notice that the wording in the problem, it says which flavor is on top doesn't matter. So CV and VC would be considered to be the same. We can't have V and V because we have to have 2 different flavors. So all we can have are vanilla and strawberry, and vanilla and butterscotch. And then when we get to strawberry, we've already listed strawberry and chocolate. We've already listed strawberry and vanilla. We can't have strawberry and strawberry, so strawberry butterscotch is the only one remaining. And if we take a look at butterscotch, we've already listed all of those, and so here are our 6 possibilities. Now, we can use the ideas of classical probability because of the statement that all flavors are equally likely. For this particular problem, I think that's kind of unlikely because the combination of strawberry and butterscotch is probably not awesome, but you know, this is a math stats problem, so we're just going to go with it. If we count all of the outcomes that we have, we can see that there are 6 different cones. For those of you who've already studied a little bit of statistics and believe that this is a combination, you're quite right. You could do it in that way as well. So, part B, what's the probability that a random customer will order chocolate as one of the 2 scoops, again, because all of the cones are equally likely, then we can say the probability of chocolate. And I was careful to make sure that all of my flavors started with a different letter. So probability of chocolate is just the number of cones that have chocolate with them, so N of C over N of total. And if we take a look at our sample space, we can see that there are 3 of them, the first column here in effect. And so we get that it's equal to 3 events divided by 6 events, and that's equal to 1/2. Or if you prefer, you could write that as 50%. Honestly, totally fine either way. Part C, what's the probability that a random customer will order chocolate and vanilla? So the probability of chocolate and vanilla, we're just going to write it using, well, standard actually kind of Boolean notation. So is equal to N of CV over N total. Now we're just going to scroll up and take a look at our sample space again. We can see that there's only one instance where we have chocolate and vanilla, and so the numerator here is going to be 1 divided by 6, and so the probability of chocolate and vanilla is 1/6. In other words, it's one of the 6 cones that you could get. Part D, what's the probability? That a random customer will order chocolate or vanilla and we're going to write that as P of C or V is equal to the number that contain C or V all over the total. And then just scrolling up, we're looking for C or V, and I'm just going to circle those. Here's C or V. All of these have either chocolate or vanilla or both in them. And so we get that that's equal to 5/6. And then we get to the annoying part, which is part E, which is calculate part D again using a different method. You could say that the probability of C or V is 1 minus the probability of the negation of that, neither C nor V, and the only cone that doesn't have chocolate or vanilla in it is the one that has strawberry and butterscotch, which does not sound awesome. And we know the probability of any one cone is 1/6, and so we get 5/6 again. But of course, I'm not going to let that alone. We're going to calculate part D again using yet another method. And if I ask this in a test, I'll get you to show your work so I can tell the difference between all your methods. You could say that the probability of chocolate or vanilla is equal to the probability of chocolate plus the probability of vanilla minus the probability of both chocolate and vanilla. And that's equal to 1/2. We calculated that earlier. The probability of getting one particular flavor as one of your scoops is 1/2, and then the probability of getting both chocolate and vanilla is 1/6. And you can see that once again we get 5/6.